welcome to the first ever session of our new BlazeMaster Tips and Tricks webinar series. Today, our Cpvc experts will be discussing 3 different topics: installing in extreme temperatures, servicing existing Cpvc systems, and then last but not least, the proper use of solvent cement. And then if we have time, we'll open it up for questions at the end. And speaking of questions, thank you very much to those of you who submitted questions beforehand. But if something comes up during the webinar and you have a question, please type it into the Q&A section, not the chat box, the Q&A section. We have 2 of my Lubrizol colleagues manning the Q&A chat: Jeff Ramey, who is the Cpvc piping systems consultant in the Pacific Northwest, and Michelle Knight, who is our technical services engineer. And just so you know, if we don't get to answer your question during this webinar, a Lubrizol rep will follow up with you after the webinar to help answer your question. Also, we are recording this webinar and we will email everyone a YouTube link once the recording is posted. So with that said, let's meet today's panelists.
My name is Jeff Landon. I'm a territory manager in Southern California, and I've been with Lubrizol for 14 years, and I work both in the fire protection industry as well as the plumbing industry, residential and commercial.
Good afternoon, everybody. My name is John Pritchard. I'm coming to you from right outside Chicago, Illinois. I've been in the pipe trades pretty much my whole professional career, and I've been with Lubrizol now for 13 years.
My name is Paul Winstead, and I was a fire sprinkler contractor for 30 years, and I'm in the Atlanta, Georgia area. And I've been blessed to be with the Lubrizol Corporation now going on 8 years.
Great, thanks guys. And I'm Lainey Leota, the Fire Protection Market Manager responsible for BlazeMaster Cpvc and our new UL listed FreezeMaster Antifreeze. Now let's get this thing started. All right, the first topic is installation. And we had a few really good questions that were submitted to us by the field. And the first one is, what do I have to do differently if I'm installing Cpvc in really cold weather?
I'll handle that, Lainey. Thank you. Well, I live in Chicago, but my market takes me to North Dakota, South Dakota, Minnesota. So we deal with cold weather installations every year. And the first thing you want to do is make sure you're taking care of your material. The first and most important is probably how you handle your pipe. Our manufacturers recommend when you get below minus 50 degrees Fahrenheit not to use ratchet cutters. And then the second most important thing is your solvent cement. That's really your chemical in there is your bonding agent for the chemical solvent cementing process. So trying to keep that warm throughout the winter is vital to a good winter installation.
And then what about cure times, John? Is it different in cold weather?
You are going to have longer cure times in cold weather, and we would refer you to the manufacturer's cure time charts, which are available from many different resources.
All right, and now the opposite for someone in a bit warmer weather than Chicago. What about installing in hot weather? Is that any different?
Oh, yes. And hey, John, you want me to get this?
Yeah, you go ahead and you cover the Southeast there, Paul. Okay.
I apologize, Jeff. Didn't mean to jump in on top of you. But yeah, especially down here in Atlanta, in Florida, where it gets really hot outside, hot and humid. One thing about your solvent, cement, the impact modifiers, the solvents that's the chemical that makes this, with the lid off of it can flash off, and when they're flashing off, you're actually losing the the bonding agent that makes the solvent weld. So yes, it's very important in a hot weather environment like in the Southeast is to when you make your solvent weld, put the lid back on it. That's about as simple as I can say right there, Lainey.
Jeff, how about in a drier, hotter climate like in California?
You know, be ready with your pipe is typically up in the air. Okay, your fitting is in hand. The hotter it is out, the shorter period of time that you have to get things correct. Okay, so obviously the condition of your solvent matters, and we're going to talk about that in a little bit. But being mentally ready to make the solvent welded joint, do all your preparation, get the solvent on the pipe and realize that the hotter it is out, the shorter amount of time that you have to get that fitting positioned exactly where you need it. One of the things that you should not be doing is once it's set and once it is set and it's kind of adhered between the pipe and the fitting, you don't want to break that set to continue to move it into position. So you're dealing with shorter amount of time in getting it properly positioned, and you got to be mentally ready to work quickly.
Great, thanks guys. So I think we have all climates covered there. The next question is something that I think all of us get all of the time, and it's actually a pretty common misconception. So I'm excited to hear what you guys have to say about this one. Should you be concerned about exposing BlazeMaster to UV light prior to installation? And then what about after installation?
I'll take that, Lainey. One thing about with CPVC, impact modifiers, the compounds that's been added to extrude this pipe. One thing about it is it's whether it's sitting out in the sun, the sun coming down on it can cause those impact modifiers to flash off. But what's occurring there is the pressure bearing capabilities of the pipe are actually increasing. So the pipe is actually becoming stronger. So it's not actually hurting the pipe at all. But what generally is the manufacturer, whether it be Tyco, whether it be Viking, or whether it be a Nipco, they like to see their pretty orange pipe. Okay, so yes, just like you would take care of your pipe, whether you're dropping it or hitting it with a hammer or whatever in cold conditions or warm conditions is, yes, you want to protect your pipe, but the UV is not going to hurt it.
And does that differ from storage and being stored outside, and then can you install CPVC exposed and it be exposed to sunlight?
You cannot, your question is, can you install BlazeMaster exposed in sunlight?
Yeah.
No, BlazeMaster can be exposed as long as it has a smooth, flat, horizontal ceiling, but you cannot expose BlazeMaster outdoors. Got it.
Can I add a little bit on the UV? So
go right ahead. Yeah.
Sure. I get this question a lot. Obviously, the inspectors out there don't like to see faded pipe, and Paul's made it pretty clear that the sunlight does not does not damage the pipe. It simply takes impact modifiers out of it, impact inhibitors, as I like to refer to, and the pipe becomes a little bit more brittle. I want to say almost as if it's aged pipe. Aged pipe also loses its impact modifiers. So, but there's a number of times where I get questions as to is something wrong with it, and nothing's really wrong with it. However, your inspectors and the inspectors that are out there do not like to see a faded pipe. So therefore, protecting it prior to installation is obviously advised.
Great, thanks, Jeff and Paul. So moving on from that question, a little different realm here is, can someone go over the cutting tool options for CPVC pipe?
Well, I have a couple. I'm going to take that one, Lainey. Okay, so I can jump on that one. So it's on the screen here. I'm holding probably in my marketplace the most common cutting tool for BlazeMaster CPVC. This is a ratchet cutter. This one's specifically designed for smaller pipe, and you can kind of hear the way that it functions. This tool is not recommended below 50 degrees because it has the ability to potentially crack the pipe. But this will give you the clean, straight cut that you need, which is one part of our installation instructions. It often surprises people in my marketplace when I demonstrate this tubing cutter with a plastic wheel on it as to actually how quickly this cuts the pipe in compares to the ratchet cutter. This is a very efficient and quick cutting tool, particularly for some larger diameters. This one is made for up to probably about inch and a quarter pipe, and it's really quick to use. Now, other cutting tools that are out in the marketplace, there are larger versions of tubing cutters. There are larger versions of ratchet cutters. They're completely acceptable. And then we have our power tools. We have a variety of different tools for larger pipe that can cut. And as far as we're concerned, all we need and we want to see is that clean, straight cut that we go on in our trainings, because the strength of the solvent welded joint comes from the deepest part of the socket. And if you are not cutting your pipe straight, you're losing that deepest part of the socket on part of the fitting, and you're not going to have the strongest joint. Anybody want to add anything, you guys? You guys got any other cutting tools that are popular in your market?
What you said there, Jeff, is exactly what we're using down here in the South. We're using ratchet cutters and wheel type cutters.
Okay.
All right, and then the last question for this section is, why is it necessary to ream and chamfer the pipe?
I'll take that, Lainey. As Jeff just mentioned, there's various ways to cut the pipe. Part of the reaming and chamfering is to make sure the exterior of the pipe does not have any sharp edges. So when you push the pipe into the fitting, if you have a sharp edge, there's a potential that you may scrape the solvent cement and actually create a future leak path. So it's just one of the steps in a good solvent cementing process is to make sure that you have a smooth, rounded edge, so you don't, so you eliminate any possibility of scraping solvent cement off the joint.
Great, thanks, John. Does anyone have anything to add to that, or should we move on to the second topic?
I think John got that pretty dead on, right on the money.
All right, great. All right, so our second topic is servicing existing CPVC systems. And the first question is, what is the cut-in procedure for altering or repairing existing systems?
I'll handle that one as well. There is actually a UL recommended cut-in procedure, and we really spend a lot of time with this, and really a cut-in procedure should be followed once you have introduced water into the system. So you may install and go to test a new system, and once you put water in it, the concern is even though you can drain as much as you can of the water, there's still going to be humidity inside the pipe. So of course, the first step is you're going to want to turn off the system, drain as much water as possible from the system. And when you cut into it, you want to make sure where you are going to assemble the new joint that you wipe clean any possible moisture that may be in the system. We're going to recommend that you use a new solvent cement can. When you first open a can, the solvents are the most potent in there, and it just helps and gives you a little extra strength in your solvent cement joint. If you're a service guy, you can always give that can then to your production crews for their production. So once you have done your joints, the most important thing is your cure times are going to be extended. And really that's a safety factor put in there because you can't quantify how much humidity is still inside the line. Once you make the final connection, you're trapping whatever humidity is left in there. People ask all the time, could I take a hair dryer or something to, make the cure times faster? That's not going to help you. We always say to follow the cure times, and they are 2 to 3 times longer than they would be for a new installation.
Thanks, John. And then a very common question is, does all of the water have to be out of the system?
I'll take that, Lainey. It's like, just piggybacking off of what John said, are you going to be able to get all of the water out of the system? And that's going to be, if you're a fire sprinkler contractor or a sprinkler fitter, you automatically know the answer to that question. You're not going to be able to get all of the water out of the system, especially when you're where you're cutting into a new drop or a T or a 90 to make an addition into another room. But what John said, when you make that cut, you make a good straight cut, you bevel that pipe, you follow all the same procedures that you would for new installation. But you really got to get that you got to get the inside of that pipe dry. You got to get it just as dry as you can. Like John said, you use a new can of solvent, you put it on there, you really make a good solvent welded joint, you put it back together, and you really work to get as much cure time as you can, because you just don't know how much humidity is in that pipe. John made mention about a hair dryer. Back in my days as a contractor, we wouldn't use a hair dryer to try to cure the pipe, we would use a hair dryer to try to dry the inside of the pipe to try to get get as much water out of there as we can. But you're never going to be able to get all the water out of that system. So just get yourself a longer cure time. Explain that to your customer that, hey, this is we're tying into an existing system and it's going to take a little longer to cure.
Can I chime in a little bit, Lainey? So
Go right ahead.
okay, so I know John covered it and we covered our cut-in procedure, but I wanted to just reiterate to the attendees that our manufacturers have a cut-in procedure in their manuals. It includes the recommendations that John went to. I'm pretty sure John said it once, but I often get people that the reason it's there is because the insurance industry that was early on dealing with alterations to CPVC systems and occupancies, the insurance industry wanted a cut-in procedure. And just so you know, our manufacturers' BlazeMaster installation manuals, they're a UL reviewed document. They are essentially the code for installing the BlazeMaster CPVC. So when our UL review document says in a cut-in application that we don't acceptance test, okay, we don't pressure test more than 50 psi over the operating pressure of the system, that's there for a reason. It's there so that if you're in an occupied building and you put it on a 225 psi test because the fire official wants it to, and you blow the joint off, now you've done a lot of damage, and we want to avoid those. So I haven't had a conversation with a fire official in a little while about this 50 psi over the operating pressure of the system, but that is our UL listed cut-in procedure does call for a number of details that all of you can reference by looking at our BlazeMaster installation manuals online. They're always available on all of our manufacturers' websites.
Great. Thanks for that added detail, Jeff. Appreciate it.
You're welcome.
All right. And this is another one I think that comes up in your area a lot, Jeff. And that's, how do you handle and repair old BlazeMaster pipe that is brittle?
Blazer, huh? So that's a
Blazer, yeah.
okay.
Brand new.
So, all right. How do you handle? Well, I don't like, but I want to discuss older pipe with people, okay? Because older and brittle kind of go together, and we want the industry to understand what is normal with our product, okay? For those of you who don't know, in California, we have a residential sprinkler ordinance, and we've actually had residential sprinklers going into some of our marketplaces in Southern California and Northern California, even before our 1984 UL listing. In the early 80s, before CPVC was listed for residential, for ordinary hazard and light hazard occupancies, excuse me, not ordinary hazard, but we had PVC being used for residential fire sprinklers, okay? And one of the things, and I bring that up because we got a lot of older systems, okay? And when a fitter or an installer or a building owner goes to alter, modify, or repair an older BlazeMaster pipe or fitting, they should not be expecting it to be the same as it is when it's brand new. The impact modifier, the impact inhibitor that we put in the pipe and the fittings, that comes out over a period of time. And now this translates directly to the way that the installation takes place today. For the fitters that are on this webinar, this is why we train you to install the pipe clean and straight. We don't want stress on fittings. The impact inhibitors are going to come out in that fitting over a period of time. Stress left on a fitting is going to put undue stress and potentially make that fitting not make its full life expectancy. Okay, so understanding that pipe is brittle is the first thing. Now the question is what do I have to do to deal with it? Okay, and there's a number of things. First of all, if you're pulling a sprinkler head in an older occupancy and you know that it's CPVC, I'm going to encourage you to do as much as you can to support that drop, because if you crank on that sprinkler head, okay, you have the potential up at the T or the 90 up above, or maybe even the drop, you have the potential to crack that pipe. Now I know this is sometimes difficult, okay, But the fitters that do the where we run into problems often is somebody comes from the field and they're used to brand new CPVC, and then all of a sudden they're dealing with old CPVC. Now the other thing that is normal is how do I cut it? We do not use ratchet cutters. Okay, we could use a tubing cutter, although this tubing cutter that I showed you earlier probably isn't going to get into a lot of tight spaces. They make low profile tubing cutters. Most of my older retrofits or alterations that go on, the contract base simply uses a fine tooth saw, something that's got very easy to get into place. We still want the clean straight cut. You just don't want to put compressive load on the pipe. And by the way, we covered earlier that the pipe is not bad when the impact inhibitor comes out. The pipe still has the pressure bearing capability. In fact, it has more pressure bearing capability because the tensile strength increases as the impact modifiers come out. So you got to be really careful in supporting the drops or supporting the system as you're cutting it, and you need to use the proper tools and take that into consideration in the space that you've created for working on things. Anything to add, Paul or John? I know I rambled a little bit, so
No, Jeff, that right on the money. I was just thinking, and what I've seen in the past is, you talk about a fine tooth hacksaw blade, and we're not talking about a sawzall, an electric sawzall. We want, just take your time and cut through that pipe. It's, more likely you're on a T&M job anyhow. So you want to take that fine tooth hacksaw blade and just make a really nice cut through there. And I think it'll all turn out perfect, if you just follow what Jeff's instructions there.
And John probably covered it. I'll add just a little bit, is that you want to make that solvent welded joint first in whatever you're doing. That solvent welded joint from the old pipe to the new fitting, that should be the first solvent welded joint that you make in that system. That's part of our cut-in procedure. That's going to give you the longest amount of time on that that critical connection between old and new.
Great tips. And then this is a relevant question. What is the life expectancy of a BlazeMaster CPVC system?
I'll answer first, because the life expectancy of a BlazeMaster system, I think it'll outlive every one of us on this call right here, added together. A long time.
More than 50 years is the
more than 50 years. More than 50 years is the correct answer. Okay.
All right. Next question. Can I retrofit or repair a steel system with CPVC pipe and fittings? John, do you want to take that one?
Sure. We call, when you combine steel and CPVC, a lot of the people call those hybrid systems. They're very common in new construction, and you definitely can transition from steel to CPVC. Currently on the market, there's CPVC by male and both female threaded adapters, and there's actually CPVC grooved, and then CPVC by brass grooved connections as well. When you go to a groove, it's going to be the industry standard groove, and we're going to ask you to use a flexible coupling and follow the criteria from that flexible coupling manufacturer. So it's definitely something that's very prevalent. We'll see it too with CPVC and flex heads as well. Those are metallic based, and those can be used with CPVC as well.
Great, thanks, John. All right, the next topic is the proper use of solvent cement. And I think the first good question to ask in general is just, how do you know if your solvent cement is in good shape?
I'll take that, Lainey. One thing about your can of solvent, it's actually the most important tool that you have when you are solvent welding CPVC BlazeMaster. It's the most important tool you have, okay? Because this is actually what's welding the fitting and the pipe together. And if you don't have good solvent, cement, you're not going to work that day. You're going to get to go home because there's nothing you're going to be able to do, all right? And seriously, you know, we talk about this in our training. On the bottom of a can is the life is the shelf life, and usually it's 2 years from the date on the bottom of the can. And here's what I do when I train sprinkler fitters is once you open the can up, that date on the bottom goes out the window. Okay, now it becomes a judgment call on you on whether or not this solvent is still good. So you want your solvent to be good and loose. You want it to be able to move fluidly throughout the, you know, when you're shaking it up. You don't actually, I can imagine, say where John's at up in Chicago, when it gets down into, it gets below freezing at night, you would not want to leave your solvent on a job site in a freezing condition, because I guarantee you the next day when you come into work, you're not going to be able to work that day because your solvent is going to be all thick. And you're not going to be using it. You're going to have to take it. You're going to have to put it in a room. You're going to have to let it come up to temperature. So it's very important to keep your solvent good and loose. Keep it good and loose. It's always, I know when you're on a job site and you're working and you're going from one solvent weld to the next solvent weld to the next solvent weld, you don't want to have to put the can, you don't want to have to put the lid back on the can, but you should always make a practice to keep that, if you go to lunch, you go to break, to put your lid back on your can, okay? Because you don't want any of these chemicals flashing off. So really, this is very important. Your solvent, I'm telling you, your solvent is probably one of the most important tools you'll have in installing BlazeMaster pipe. Always take care of your solvent. John, Jeff, you got anything to add to that?
No, I think you covered it pretty well.
Yep. Good job.
Awesome. Great job, Paul. Thank you.
Thank you.
Next one's kind of a fun question. What are some of the most creative ways you have seen people address the fumes or odor of solvent cement on a job site?
I'll take this one, Lainey. Anybody that's ever worked with solvent cement always has that question. And the first thing, you know, the government regulates how much VOCs can be in solvent cements. But what you're smelling is actually the acetone. The acetone is designed to actually soften the pipe and fitting for the solvent cement process. It's actually counterintuitive to what you think. You're softening both the pipe and fitting, you push them together, and that's really what the chemical bond creates. In new construction, you know, when you're not in cold climates, something as simple as opening a window and getting ventilation through the building or where you're working is pretty simple. But as we have different criterias, you may be in an area, a basement or a room that doesn't have good ventilation. The simplest thing I could ever recommend is going to a big box store and you can get a 2 foot by 2 foot box fan for $20. Air circulation and evacuating that solvent. And quite frankly, in the summer and the hot months, it can help cool you off a little bit. The number one question we get typically with this is when you're doing repairs inside an office. Retrofits of care facilities have been vital in the last 10 years, and this is always a concern. You can buy from companies that make actually a flexible fabric ducting that you can use to evacuate it. You can buy the systems that actually have, you know, a blower built right into them. You could actually, if you're creative, you can buy that same flexible ducting and just use that same box fan at a big box store. Air movement is critical component to evacuating any kind of acetone smell that you're going to have, especially when you're inside a structure where people are working.
Thank you, John. Anything to add to John's comments, or are we good there?
No, I learned something from John's comment. That was very good.
Awesome. All right, next question is, any tips relating to the solvent cement daubers? What can be done to strengthen them so that they don't break off?
Yes, about the in your can of solvent, depending on whether it's for fire protection, you're gonna have a 3/4 inch dauber in there. If the dauber breaks off, actually your supplier, where you're buying your solvent from, ask him, he can give you additional daubers. It's just a real thin piece of metal in there. I've never had, in 30 years, I've never had a problem where the dauber broke off from the top of the can. But there are daubers out there. You can get additional dauber. Ask your wholesaler. Ask your wholesaler, whoever you buy your pipe from, your fittings from, your solvent from. Hey, throw me in some extra daubers in there. So that's very simple, Laney. But I mean, if you don't have a dauber, go get a dauber. Don't try to pour it on the can or use a paper towel or anything like that. Go get a dauber. Go get the right size dauber for the diameter pipe that you're using, and you'll be fine.
So
Can you elaborate on that, Paul, with the right size dauber for diameter pipe or somebody?
What now? What'd you say? I'm sorry, Lane. What'd you say? It's usually half. The dauber size is half the diameter of the pipe.
So typically in our fire sprinkler business, we're going to have cans that have 1/2 inch dauber for our smaller pipe. Okay.
Yep.
Okay, that's going to be able to do 3/4 inch, 1 inch, maybe 1.25 pipe, and then you have larger daubers that are available on the cans under a different under a different part number that'll be able to do your 1.5 to 2.5 and 3 inch
Right.
pipe. It's pretty much a 2 dauber application. Just so people on the call know, most of us with Lubrizol, we deal with our plumbing and industrial applications as well, where there's probably 4 different size daubers. They use swabs and rollers on larger applications. But for fire protection, 2 size daubers, and the dauber on the can isn't always the right size dauber.
That's true.
I would add one thing to this as well. A good place if you really had to get a dauber, and I'm going to put it up there, I don't know if you can see it in the camera, you can go to a big box store in the plumbing aisle, and they actually sell daubers, and they're really sized in between what you would get in a pint and a quart can, and they actually are pretty sturdy, and they have an adjustable stem on them as well. When you're out in the field and something breaks down, you may not have a wholesaler, a fire protection wholesaler close by. Chances are you're going to have better luck in an emergency to go to a big box store, whether a Home Depot, Lowe's, and in the plumbing aisle, you can typically find these. They're very prevalent.
Great, thank you guys.
Yeah, we just don't want to see it. We just don't want to roll up on a job and see you with a 1/2 inch dauber trying to apply solvent to a piece of 3 inch pipe. Okay, it is, and not to make fun of, not make light of it, but it is very important to use the proper size dauber for the proper size diameter pipe.
It's not only very important, but a lot easier too.
Yes, ma'am.
All right, so next question, Jeff, is can you show us how to properly solvent weld a joint? And then there's a question here that I really like, and it's, one second, where'd it go? It had to do with identifying, what should you be looking for to identify issues or potential points where it's not installed correctly.
Okay, I saw that question that came up in the chat here, and one of the benefits of COVID is that we've all gotten reasonably well of doing virtual demonstrations on things. Hopefully, you can all see some of the orange BlazeMaster Cpvc on the table here. But we're going to go through how to do a solvent welded joint, and then we'll remind me to talk a little bit about what to look at, because if you're an inspector or if you're a quality control person on a job site, you're really looking at the outside of the pipe. Okay, so let's go through the 5 or 6 steps that we would normally go through. Lainey, is everybody seeing my screen okay? Because the screen I'm looking at has you up on the screen, Lainey. So
Looks good, Jeff.
Okay.
You're good.
So we're going to start with our choice cutters. My cutter for this demonstration is my Ratchet Cutter, made by MCC, sold at one of my BlazeMaster distributors. Okay, and we're going to look for a clean, straight cut. Now we realize that the pipe isn't always down in your hand. The pipe is very much up in the air. But this is step number 1. Step number 1 is to make a clean, straight cut. And for those of you that it's worth pointing out, this is a very sharp edge right here, okay? And this is why we pick up step number 2, which is probably the most common beveling tool in my marketplace, is this rigid, I think they call it a plastic beveling tool. And this does both the inside of the pipe and the outside of the pipe. Now I'm going to demonstrate another beveling tool for you, because you can go on Amazon or go to your distributors and get a variety of different tools these days. But this goes one direction, and we're going to take it off the outside, turn it around, and we're going to go on the inside. And if you note it, and then I'm going to reach in, I'm going to clean off that debris, because this leaves a little bit of a shattery type of debris that we don't like having a lot of in the system, because it gets into valves and it needs to be bled out of the system. But my beveling process has taken the edge off so that I no longer have a sharp edge. Now, if you choose, I'm going to demonstrate right now one additional beveling tool. This one is made by Ream, and there's a number of them out there. This only does the outside of the pipe, but if you'll notice, it gives you a nice big fat curly Q. Some of you saw that come off here, but it rolls off and it does a beautiful outside edge, but it actually does not do the inside. You need to use some sort of interior tool to do the inside, okay? So this is a two-tool operation, but either way, on the piece of pipe that I have in front of you now, I now have two prepared ends. And the next thing is that we want to test our pipe and fittings together. I put this together and I get a tight fit. I test it. Now, here's a question that comes up, and I'm going to speak kind of directly, is we often get asked, how do I avoid dry fits? A dry fit, for those of you who are not familiar with it, is a fitting that is simply put on the end of the pipe and left there. And then at some point when we do a pressure test, we realize it was never solvent welded. And I'm going to be a little bit facetious, but a little bit serious as well, because this is a serious issue. The biggest way for you installers that are on the line and on here watching it is, you never leave a fitting on the end of the pipe that is not solvent welded. Never, ever, ever, ever. That's how you avoid dry fits. Okay. We have other ways that I'll talk about after we finish the solvent welded joint, to bring accountability to job sites so that there's ownership on the solvent welded joint. But either way, when I test fit it together, I get a tight fit. This tells you something about the bottom of this fitting socket. And this fitting socket is smaller at the bottom and it's larger at the opening. It's called an interference fit, and it's by design. And for those of you who want to see a good joint, this is a cutaway that was provided by Lubrizol. But this is something I want to show you here, is where is the strength of my solvent welded joint? 80% of the strength of the solvent welded joint comes from the deepest third of the socket. See where I got this little interior reaming tool? This is where the strength comes from. So if I don't cut my pipe square and I miss the bottom of the socket, I'm losing strength. If I don't chamfer the pipe and I leave my sharp edge on it, I'm going to fool myself that I made the bottom of my socket, because my sharp edge is now dug into the side of the pipe, and I'm going to think I made the bottom of the socket, but I just made a solvent welded joint and left it in the system that is not as strong as it could be. Is it going to have a problem? I don't know, but it's pretty easy to tell if there is a problem. What the problem is, it was never chamfered. Okay, so when I test fit my pipe and fitting together, I get the tight fit. I never leave the fitting on the end of the pipe, and now I'm ready to do my solvent welding process. So I get out my solvent. Let me move a couple tools here so we can kind of stay screened. I have a solvent. The solvent that we use for BlazeMaster fire protection systems is specifically made for fire protection systems. It is red in color. So our gentleman that's asking about inspections, it should be a one-step red solvent. And my half pint of solvent here has a 1/2 inch dauber on it, and I have 1 inch pipe. Good combination, about half the size. This 1/2 inch dauber will do both 3/4 inch, 1 inch, and maybe 1.25 inch pipe, maybe. So I get my 1/2 inch dauber, I manage my solvent, and I go to my pipe first. I want to go all the way to the depth of the socket, and I want to go around several times. I go to my fitting second, and I put it all the way to the bottom of the stop. I put this together, and I rotate it, and I hold it. you're typically going to be like this. Now, fitters, I recognize that your pipe is up in the air. And I often see a lot of people in the field that will go fitting first because it's in their hand. The reason why we train to go pipe first, fitting second is because we do not want big puddles of solvent in the bottom of our system. Hopefully you can see the bottom of my fitting reasonably well, but if you notice, if I don't manage my solvent on my dauber well, and I'm going to put it on the outside of the pipe, and then I take the half loaded or minimally loaded dauber and I go on the inside of the pipe. Why do we avoid big puddles in the bottom of fittings? Because our solvent's job is to soften the pipe and soften the fitting and chemically weld it together. If you leave a puddle on the bottom of a fitting, your solvent isn't going to know that it's in the bottom of a fitting. It's just going to simply soften. Now, there are those in the industry that want to do a little cleanup and a little wipe. I pulled out a rag so I could do that. But how long, this is how you make a proper solvent welded joint. And I have made the full bottom of the socket. You can see all the way in there. That is all the way up against the edge. I have a full bead on the outside of the pipe. And obviously, it would be in the position that I need it to be in for where I'm running in the building. Now I'm going to pause for a moment and let John and Paul say something. Is there anything, John and Paul, that you would like to add?
Jeff, I can't add to that. You did a really good job.
Okay, all right. So let me do this. For all of my Ratchet Cutter believers, I want to actually show you this because this is a tubing cutter that's used in other parts of the country where it's not hot. And you want to see how quickly this tubing cutter can cut straight? This is a really good tool, okay? Gonna go within like 3 turns. I have a cut end of the pipe, and I was not forcing that. These tubing cutters are very, very quick tools, and they do not put that compressive load on it that we don't recommend below 50 degrees. Now, I'll add 2 things, and I'm gonna change my camera here. I'm gonna walk over, change my camera. Is when I'm making solvent welded joints on larger pipe, I need to use more solvent. That's pretty common sense, okay? But I would go pipe first, fitting second. For my bigger pipe, I'm going to say 1.5 inch, 2 inch. Okay, I got a lot of 2 inch and 2.5 inch pipe that's used in my marketplace. I got a lot of 3 inch pipe that's used for underground private fire mains. When you're doing solvent welding joints on those bigger pipes, there's 2 things you need to consider. A second application of solvent to the pipe, because the bigger the pipe, the more fill you need behind the point of contact at the bottom of the socket. And the second thing that you need to do is I encourage you to hold it for a long period of time. And it's not a specified period of time, but the bigger the socket, the bigger the pipe, the tighter the socket, the more that it's going to want to push back on you and slide back. And you want to hold it to the depth of the socket until the bonding starts to occur. On bigger pipe, on smaller pipe in cold weather, we put 30 seconds in our manuals. In my market in the deserts and when it's hot in the summer, it's literally 6 seconds. Okay. So, but on bigger pipe in moderate weather, that's going to want to push back on you. And every bit of the socket that you miss at the very depth of the socket is strength that you're losing in your solvent welded joint. And I'm sure there were some questions there. So, okay. Want to start managing them, Lainey? So.
Yeah, sure. First of all, thank you. That was an awesome demo there and really good to see. Before we start with the Q&A section, I just wanted to ask John and Paul if there was anything you had to add to Jeff's demonstration in terms of tips or anything like that.
I wrote in the chat line, great job, Jeff, which it was. The only thing I would recommend is when you get to the larger diameters, 2 inch and above, it sometimes is not a bad idea to maybe put a reference mark in there to make sure you're bottoming out the pipe into the fittings. The fittings are designed in what we call an interference or tapered fit. So it's designed that as you push the pipe in, you have some resistance. Just to make sure that once you get there and start feeling resistance, that you don't stop. A reference mark is always a good way to visually see that you're actually getting the pipe to the bottom of the fitting socket. But great job, Jeff.
Great. Okay, we have perfect timing, 15 minutes for questions. So if you do have questions at this point, please type them into the chat. And then there are, I think Jeff and Michelle have been doing a great job at getting to some questions, but there are some that I think would be good to answer and just chat with you guys about as well. The first one is there a proper way to cut 2-inch or bigger pipe when it's really cold out, like below 20 degrees?
Hey, there you go, John. That one's yours. So.
Well, ideally, you always want to try and work as warm environment as you can. Probably the best advice I can give you in cold weather is to try and keep your pipe out of high traffic zones, possibly elevate your pipe onto a work stand. If you use a chop saw, which some people do for larger diameters, one thing you're going to want to use is a fine-tooth saw. And two, most importantly, is to get that chop saw up to its top revolutions before you start cutting. A bad habit people have is turning the chop saw on and throwing it down on the pipe when it really doesn't have enough RPMs, and it bogs it down and can create a problem. A lot of people use those small Sawzall type saws. They are good for smaller diameter, but you always use a fine tooth saw. But really for larger diameters, it's probably best to use a chop saw to get a good straight cut, provided you follow the parameters that I just recommended.
Great, thanks, John. Another thing having to do with weather-related installs, any tips regarding the installation and accounting for thermal expansion and contraction? In particular, how is the pipe supported?
I'll handle that as well. When we install pipe in cold weather, there's installers sometimes are forced to install in 0 to 10 degrees Fahrenheit. And unfortunately, a lot of times what we see at a typical hotel or apartment, they put temporary heaters in there and heat up your mains, which could be running in the hallway. And what we quantify when we figure our expansion loops and compensating for expansion, we work on what we call a delta T, or change in temperature. So you may go from 0 to 10 degrees up to, quite frankly, 100 degrees Fahrenheit. So in the winter, you're going to have to be more cognizant of that pipe having extreme growth due to that temporary heat that may be creating that situation. If you're installing in 70 degrees, which is a perfect world, you're going to have far less expansion to deal with. In the summer months, you're going to be actually installing pipe that's expanded, and as they cool down the building, it will be contracting the pipe. So we still always stand by our recommendations that once you have a run, typically over about 30 feet, you want to start thinking about expansion and contraction. And all our customers have a simple chart you can utilize. You look at the size pipe you have, the length of the run, and it'll give you options, whether it's an expansion loop, change in direction, or offset to compensate for that expansion in the system.
Thanks, John.
Can I add one thing, John? I think you probably said it, but a key thing in accommodating the slight expansion and contraction that's going to naturally occur when there's change of those temperatures is all of our supports allow the pipe to move within the support system.
Right.
We don't pinch our piping tight any type of in our support systems. Support is meant to support for water for water weight based upon the charts that are in our manufacturer's manuals, and they always include the ability for the pipe to move within the supports.
Yeah.
One other good thing to remember too is you may see a pipe that's bowed or deflected, And when we talk about expansion contraction, pipe is forgiving, fittings are not. In our installation guides, there are parameters for allowing deflection in the pipe. Sometimes code officials see it, they think there's something wrong with the system, but there is a minimal amount of deflection allowed in the pipe depending on the distance, and that's actually acceptable per the manufacturer's recommendations.
Great, thanks guys. Next question is, what precautions do we need to take when feeding new CPVC piping from an existing steel riser, for example, one that's 30 years old? Do you have to be worried about any residual oil or other substances in the steel pipe that aren't compatible with CPVC? So kind of two separate questions there.
I'll take this one because I dealt with one of these here just recently, or I'll start and you guys can add something in. Okay, so we have an older system and we have a section of the system that is steel. We're probably going to do another one of these tips and tricks related to chemical compatibility and some other topics down the road. But for a general discussion is, in the fire sprinkler business, we use chemically compatible cutting oils for new installations for what we call hybrid systems. These are new construction hybrid systems that are defined in NFPA 13. So what do we do when I have a section of steel that I don't know what it is and I'm doing an alteration or a retrofit on the building? I went through this with a library here in my town in San Diego, and the contractor asked some very good questions. They said, we're going to feed this new section of the library with BlazeMaster Cpvc. Okay, we're gonna use it because we're approved for a library. It's light hazard, and we have to go through this existing main. What they came up with was a proactive flush of the existing main. Is there concerns about older cutting oil that might not be compatible still living or being in that existing steel main or riser? Yes, there is some concerns, but you want to minimize that. The way to minimize that is to, besides all the 5-year tests, all the other tests that have gone through moving water through this system. If I was the installing contractor and I had to deal with an existing riser and I didn't know, is I would add some money into my bid, I would add a little bit of time, and I would put a disclaimer in my contract that you're gonna flush to the best of your ability, again, the existing steel, and that you would not be responsible for any damage that occurs to the CPVC due to residual cutting oils. I feel very confident that those cutting oils in today's world would not damage your new system, but I'm being very practical in mentioning what I did. You got any comments, John or Paul? Does that make sense? So,
Jeff, in my previous life as a sprinkler contractor, I've faced those issues before, and I did exactly what you just said. You know, we would write it. I would write it in the contract that, you know, about an exclusion to existing cutting oils that could be, but we would flush that system. You're right. Take a little time, flush that existing system before you make that connection.
Yeah,
it's just a very smart, wise thing to do.
And just to be clear, folks, because the people that aren't, this 30 years ago, we weren't really paying attention to what the cutting oils were in the industry.
Right.
Now we've reached the point in the industry where we have compatible cutting oils and we have other cutting oils. Okay.
Yes.
So, and we have a protocol in NFPA 13 that requires that new cutting oils be compatible. So, you got anything else, Lainey? So,
There's certainly more questions.
What are we going to do? What are we going to do with all the questions that don't get answered? So
we will follow up via email or on the phone after the webinar within the next few days. Everyone's question will be answered or addressed, and I know that there's been some comments sent as well. You know, if you would like to discuss them, someone will certainly reach out to you. Next question. Are there any special installation steps that must be taken when installing a dry system using BlazeMaster Cpvc pipe from manufacturers that have been listed for use? So Viking and Tyco pipe both have that listing.
I'll handle that one. We have a low pressure dry system listing. It's been there for quite a while. We're sort of waiting for the valve technology to catch up.
Right.
And the limit is going to be at 15 PSI max. 15 psi is what our Earth's atmospheric pressure is considered at sea level. If you are going to use CPVC in a low pressure dry system, you'll still have to meet the water supply design criteria. One caveat is the pipe will have to be considered concealed. Concealed is when you have a 30-minute fire barrier. And then we would defer you to the requirements of NFPA for dry systems.
Yeah.
Great. Next question, is BlazeMaster listed for exposed residential 13 applications?
I'll touch on that again. I would think exposed residential, it's listed for NFPA 13, 13R, and 13D, provided you follow our exposed installation criteria. With 13D, we have specific listings for basement exposure. And we've actually are continually getting those modified. Most recently, we cleared up questions and concerns regarding parallel and perpendicular. But yes, in any light hazard 13, 13R, 13D, we can be run exposed, provided that you follow our direct parameters given by UL. And Jeff had mentioned something earlier that our customers' installation guides have all that information, and they're actually monitored by UL for content as well.
Yeah, the installation guide is actually part of the listing.
It's part of the listing. And while we're talking about light hazard, I saw a question in the chat. It's probably been answered by one of our chat monitors, but we are allowed to be installed exposed in a 13, 13R, or 13D in an ordinary hazard space and an otherwise light hazard occupancy. So an ordinary hazard space up to 400 square feet is our base ordinary hazard exemption, and it can, as long as you can be exposed or concealed. For those of you that there is some improvements on our ordinary hazard exemptions in the 2019 NFPA 13. NFPA 13 2019 edition allows you to use CPVC for a private garage, which is considered ordinary hazard, concealed up to 1,000 square feet. And NFPA 13R allows you to use BlazeMaster CPVC in any size ordinary hazard space in an otherwise light hazard occupancy, concealed. No limit on size. That's a 2019 improvement on our on our ordinary hazard exemptions in the code, or in the standard. I'm sorry.
Great, thanks, Jeff. Thanks for the clarification. There were a couple questions regarding heat guns. One from Dennis specifically is, we have had contractors heat CPVC with torches and heat guns to bend around other trades. Is this acceptable?
No.
Knew that one was going to be easy.
No.
Yeah.
No.
Yeah. No. So
No.
We have some ways that you can deal with moving around other trades and what are they actually in contact with. Okay. So, we have a lot of information on our FBC system compatible website, other topics section that talks about contact with things like ducting, plumbing pipe. A lot of different things are referenced very generally and in positive and informative ways. So we would encourage you to check that out if they're going around something, but the answer to that is no.
No.
So.
All right, and then I think we have time for one last question. Can CPVC be run above ceilings in ordinary hazard areas?
I'll answer that question. It can be run above an ordinary hazard in the ceiling if it's not protecting that. A good rule of thumb is it protected from the area it's protecting? So you may have a combustible concealed space above ordinary hazard in a 13, but if you're running that pipe to somewhere else to supply protection, that would be okay, but you would not be able to protect that ordinary hazard space with the pipe.
Yes.
All right, thank you, John. And it's 3 o'clock Eastern, so it looks like we're out of time for today. Once again, if we weren't able to address your question today, or you had a very, very specific question, someone from Lubrizol will be following up with you very shortly to get you an answer. Thank you again, everyone, for attending and asking some great questions. We had great conversations. Again, thank you to the panelists. You guys did an awesome job. Make sure you're on the lookout for our next webinar in the series to be announced soon. You can find more information and our training schedule at blazemaster.com and click on the training tab. Thanks, everyone, and we'll see you soon.
Thank you.
Thank you. Thank you, Lainey.
Thank you.
Bye.